Okay, this question wants us to find the Laplacian of this function. So to start, the Laplacian is just the divergence of the gradient. So we're going to have to find the gradient of this function. And we've done that enough for this specific square root function to know that grad f is just x divided by the magnitude, y divided by the magnitude, and then z divided by the magnitude. So now we're just going to calculate the divergence of this. And due to the symmetry, let's just focus on the x derivative of the first term. So we want the x derivative of x over square root x squared plus y squared plus z squared. And for this, I'll just rewrite this as the derivative of x times x squared plus y squared plus z squared to the negative 1/2. So what we end up getting is, using the product rule, x squared plus y squared plus z squared to the negative 1/2 plus x times negative 1/2 times x squared plus y squared plus z squared to the negative 3/2 times 2x. So this simplifies because we can pull out a common factor here. So we can pull out x squared plus y squared plus z squared to the negative 1/2, and we get 1 minus x squared times x squared plus y squared plus z squared. And then if we pulled out a factor of minus 1/2, this can just be to the minus 1. So now we can write this by simplifying as just y squared plus z squared over x squared plus y squared plus z squared, all to the 3/2. So then similarly, when we add all three of these together, we get a y squared and a z squared for the x, an x squared and a z squared for the y, and a y squared and an x squared for the z. And now we can see here that we actually have two copies of our radial distance on top. So 2 times x squared, 2 y squareds, and 2 z squareds, divided by our 3/2 quantity. So now we can cancel one of them, just giving us 2 divided by the square root of x squared plus y squared plus z squared. And that's it.